Hey students, let's go over this Unit 3 exam review worksheet. So question number 1 says, in Northwest Pennsylvania, a zoologist recorded the ages in months of 55 bears and whether each bear was male or female. The data are shown in the back-to-back stem and leaf below. Based on the stem plot, which of the following statements are true? The median age and median range of ages are both greater for female bears than for male bears. Okay, well, we can look at these distributions, female and male. This female distribution is skewed to the right, and this one is also kind of skewed to the right, but it's a little more concentrated here. One thing that we know about skewed distributions is that the median and the mode are going to be approximately the same. So for this distribution, your mode is somewhere in here. So your median would be there somewhere too. And for males, your mode is somewhere in here. So we don't even need to calculate this, honestly. We can just kind of wing it. So for females, your mode is somewhere between, the high 20s to 30s. So I would say it's from mid 20s to 30 without looking at the numbers exactly. And over here, this is also your median and your mode is from about 20 to 29, since we are only staying in this category. So this tells me that my female mode and median are a little bit higher than my male mode or median. So we can say that this female median is higher. And then this other thing that was mentioned over here, the first thing that was mentioned is the median, the second one is the range. Over here, I have a range of values stemming from 20 to 154. And for males, I have values ranging from 15 to 70. So the range is definitely higher for females. So after you search through your options, the best answer is A. The median age and range of ages are both greater for female bears than for male bears. Okay. Number 2, I actually made a mistake and I told you guys to skip it and you may have missed it, but I deleted option E. And option E is that the standard deviation of data set A is greater than the standard deviation of data set B. So I'm actually, and that is the correct answer. I'm actually not mad that we eliminated this option. We haven't really spent too much time on standard deviation, but looking at these other ones, option A says the mean of data set A is equal to the mean of data set B. The mean is probably somewhere in the middle, but we cannot be sure because this is an interval of 30 to 40. Same thing, the mean and the median, because both of these are symmetric graphs. They're both symmetric graphs, even though one's bell-shaped and one is kind of bimodal. They are both symmetric graphs, so the mean and the median are going to be the same value. So answer A and B are kind of addressing the same thing. They're saying exactly the same thing. So that's an indicator that they're going to be out because you can't really choose one without the other here. Okay, and because we have like a range of values here, we can't be sure that they're going to be the same. They're going to be approximately the same, but not exactly the same, okay? The range of data set A is equal to the range of data set B. Same thing, this highest bound is from 50 to 60. So is this one, my highest value here could be 60, my highest value here could be 51 for all we know. So we aren't sure that the range is the same. Data set B is more symmetric than A. That's not true. They're both symmetric. Data set B is a little bit nicer in the means that it is a bell-shaped symmetric graph, but that doesn't really mean anything as far as symmetry goes. They still are symmetric. If I were to fold this graph down the middle, these would line up. If I were to fold this down the middle, this would line up. It's still symmetric, okay? The standard deviation of data set A is greater than the standard deviation of data set B is true. Based off of what you know from standard deviation from integrated math 3 and all the way back to integrated math 1, standard deviation is the measure to which data points fall away from the mean. So if this was our mean or central value, which it is, the closer data is lumped to that central value means the smaller the standard deviation. So data here is further away from that central value, so A would have a larger standard deviation than B, where the data is clumped around that central value, for instance. Okay, for question 3, the following histogram summarizes the amount spent on plane tickets to travel home in dollars for a group of 30 college students. If the interval decreased from 200 to 100, which of the following must remain the same on the new histogram? And that keyword there is that must. So the heights of the bars do not necessarily have to stay the same. If you separate them because of these categories, we might have more values falling into the 200 to 300 range than the 300 to 400 range, for instance, so that's not going to work. The width of the bars is not going to stay the same because we're making them 100 instead of 200. The number of bars must not stay the same because we're going to expand. The sum of the frequencies is, however, going to be the same. We're still displaying the same amount of data, just in a different number of categories. So that's going to be the same. The shape of the distribution does not necessarily have to be the same. And we saw that from example would be when you make a repeated stem and leaf plot. That's kind of what this is similar to. That can reveal a different shape, okay? So the shape can look a little bit different. So it's when we take something with one interval and kind of break it down into two. That's what we're doing here too. Taking one large interval and breaking it down into two smaller intervals. So that would not work. All right, so we're talking about this comparative bar chart here. And so let's just go through these options. I'm not gonna waste time reading through the prompt. But which statement about delivery method and rate of survey return is supported by the graph? There's a positive association. Positive association means that there's two variables relating to each other, and there's not. We're looking at one variable here. Negative association, nope. Just so you know, a bar chart is displaying univariate data. So if you're looking at a bar chart, you are not looking at more than one variable. So we're not even going to count that. Okay. Question 3, the number of surveys given using the dining hall delivery method was less than the number given using either of the delivery methods. That's not true. We still got 100%. We don't know how many. So that is not true. We're looking at the rate of return. So we have 100%. Not going to work out. The psychology delivery method displays the most symmetric results. The other delivery methods display skewed results. This is a bar chart. It's categorical data, therefore skew cannot be assessed. And the last one is the in-class delivery method had a greatest rate of return, which you can see return survey. It's higher than the other two. That is your best answer. E. Okay, moving on. Consider these types of graphs, which are suitable for qualitative data. Okay, so for qualitative data, remember we're going to be looking at a pie chart or a bar chart in these options. And for quantitative data, we're looking at a histogram, stem and leaf, cumulative, relative frequency plots, any type of frequency plots right there. Describe how data outliers might be revealed in histograms and stem and leaf plots. They can be revealed by large gaps in the data. They can also be revealed because the graphs can appear to be skewed, which kind of let us know there's some strange values maybe out here in the tails. There's some ways right there. All right, moving on to number 6. Driving under the influence of alcohol is a serious offense. The following data gives the ages of a random sample of 50 drivers arrested while driving under the influence of alcohol. This distribution is based on the age distribution of DUI arrests. Okay, make a stem and leaf display of the age distribution. It is up to you, but for me, I am going to use a double stem and leaf plot or repeated stems. Remember the trick, I didn't use it, but you can if you want for your calculator help, is if you hit stat edit and put all these values into list 1 and then hit stat again, sort ascending list 1. All of these values will be in number order for you, so you can easily make a stem and leaf plot right away. One thing you need to make sure that you include when you're making a stem and leaf plot is a key of how to read it. So for instance, for this one, the 1 and 7 would be a result of 17. Okay, I'm gonna pause this video and put my answer right here for you guys. Okay, and here is what my repeated stem and leaf plot look like. You could have done one also with that did not have repeated stems, but you would have had some pretty long 2 and 3 columns, so it may give a more formative look at the data. If you did repeated stems on your test, you will be notified of which type to do, or you'll be asked which one you think would be better, okay? Next question is to make a frequency table with 7 classes showing class limits, frequencies, relative frequencies, and cumulative relative frequencies. Okay, so we're gonna make that table. Luckily for us, it tells us that there are going to be 7 classes. So in order to determine how many numbers go into each class, what we do is we take the range, largest value is 64, the smallest is 16, divide by the number of classes, which is 7, which gives us 6.86. So we should have 7 values per interval. Okay, so I'm gonna pause and pop this table up for you to show you what it should look like. You should have classes, frequency, relative frequency, and cumulative relative frequency. Okay, so here's what your table should look like. Some things I want to point out. Make sure your intervals are clearly defined. I started at the minimum, which is 16. I added my 7 values, and we go to less than 23. These need to be clearly defined so I know where the value 23 lies. Remember that this is on a number line, so I want to make sure that I'm notifying people from my histogram where each value lies, okay? And then here's my relative frequency. Just divide the frequency by the total. Cumulative relative frequency is we add as we go until we get to 100%. Remember, I'll take 99 or 101%, and that will be okay due to rounding. 1% above or below is okay. Anything else, you're going to have to adjust accordingly, okay? Now I can draw my frequency histogram. My frequency histogram just means that my y-axis is going to be frequency, not just relative frequency, and I can really have any either. So let me go ahead and put that up and we'll talk about it. Okay, so some elements of my graph you should notice is I have a labeled x-axis, I have a labeled y-axis, I have my numbers clearly defined, a break in the graph is okay, this is a number line, and my graphs are clearly the same width, okay? So that's what we want to make sure that we have. This question, identify the shape and mode of the display. What we can say about this is that the graph is skewed right, with most people between ages 23 to 27, this graph is unimodal. If I want to describe it a little bit further. All right, question D is asking me to draw this similar histogram, but just with, relative frequency on the y-axis. So let's see what that looks like and see if it's any different. So what you should notice about this graph is now my y-axis is relative frequency, same scale as above, and really what you should notice is that the graphs look exactly the same. So in regards to shape and mode, it looks exactly the same as above. Okay, we just have a slight change of scale with that y-axis, but it looks the same, okay? And why would we use relative frequency over frequency? Is this would be beneficial for comparing histograms. Especially if we're not sure if we have the same sample size or if we have different sample sizes, you would need to use relative frequency to compare. All right, now we're going to go ahead and use that information above, same table, to draw a cumulative relative frequency plot. Remember, for a cumulative relative frequency plot, your points are the upper limit and the cumulative relative frequency. Upper limit of the interval and the cumulative relative frequency. So I'm going to just list out my points here. So that we're ready to go. So there's my points. Now I can plot them. All right, so some things you should notice about my graph is I have the same scale as above. I have a labeled x-axis, a labeled y-axis. I plotted my points. They are connected rigidly, not with a curve. That's very important. I end at 100%. Discuss how this data might be used to price auto insurance for different age groups. Answers can vary here, but an answer that I came up with is that this shows frequent ages that drivers get DUIs. The group that have a higher frequency may need to pay a higher premium. So there's one example. All right, last question says, many people say the civil justice system is overburdened. Many cases center on suits involving businesses. The following data are based on Wall Street Journal reports. Researchers conducted a study of lawsuits involving 1,908 businesses ranked in the Fortune 1000 over a 20-year period. They found the following distribution of civil justice caseloads brought before the federal courts involving businesses. All right, so one thing you need to do is we're making a stacked bar chart. You need to add all of these values up because we're going to use relative frequency on our axis, okay? So we're going to use relative frequency. You can build this vertically or horizontally. I'm going to do it horizontally because there's more room. And I'm going to label my axis relative frequency. So if you did it this direction, that's fine. Your graph is just going to be tipped up and mine is going to be on its side. No worries. All right, and my bottom label disappeared. So what we should notice in this graph is that we use relative frequency on there's only one axis, so we're using relative frequency. I used mine horizontally. You could also do it vertically, like I said. Another thing that needs to happen is you should label each bar or category or chunk. Remember that for a stacked bar chart, this is similar to a pie chart where 100% of the data is accounted for in the bar. So a good rule of thumb is to stack largest to smallest quantities or relative frequencies. So that's why I did general torts first, then contracts, then asbestos liability, other product liability, and all others, so that it's easier to read. And as you increase, you start at 0.46, we add 0.26 to let us know where we put this boundary. Then we add 0.12 for this boundary, add 0.09 for this boundary, and add 0.05 for this boundary. We should be at approximately 100%. 1% above or below, remember, is acceptable. So make sure you have some kind of key, or you label each bar. So if this was not in color and you label the bars, that would be good too. All right, guys, so that's it for your review. If you have any questions, feel free to send me a remind, and I will see you for your test on Friday. It will be multiple choice and free response, just like last time. Free response in class, multiple choice as homework or over the weekend. All right, bye.